Whenever a value x approaches to some constant, the functional value approaches to the value. Always remember that the limit cannot be defined only when the left hand limit as well as right hand limit are not equal. Now the functional value is a constant function. So here f of x is equal to 3 itself. When I say x is a variable, that variable can be changed. We can certainly change different values for the x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Department of Mathematics. Today we are going to take up the new chapter, Limits and Derivatives. So in this session, we are going to learn about the limits, the definition, and followed by investigation of some function under limits. Now what do you mean by limits? So before that, let us learn the meaning of x close to a. So when I say x close to a, we denote it like this, x close to a. So let x be some variable and a be some constant function. When I say x is a variable, that variable can be changed. We can certainly change different values for the x. So now as we change the value of x, it may come nearer and nearer to the fixed constant a. So that we say as x approaches to a, and it is denoted by x tends to a. We also call as x close to a, or x approaches to a, or x tends to a. So whenever any constant approaches to a we indicate it like this. Now how x approaches to a helps us in learning the limits. Now consider some function f of x is equal to 3x. Now as x goes close to 2 for this function f of x will be nearer to the value 6, because as you go on increasing the value until 2, you can see, for example, if x takes the value x is equal to 1, then f of x is equal to 3. If x is equal to 1.2, then f of x will be equal to 3.6. If x is equal to 1.5, then f of x is equal to 4.5. Now when x is equal to 1.8, f of x will be equal to 5.2. So like this, as x approaches to 2 until 2, it will not say x is equal to 2. So x can approaches nearly 2, then f of x will take the value of 5.9999 something. As x approaches to 1.9999, f of x approaches to 5.9999. So therefore, in such case, we call that whenever a value x approaches to some constant, the functional value approaches to the value, and that value we call it as limit L. So that is the limit of the function. When I say limit, so it is the maximum or the minimum value where the function can reach. So therefore, in this example, I have shown you that whenever x goes close to 2, f of x goes close to 6. So this is how we will define a limit. So thus, a limit of a function is that let f of x be a function defined on an interval containing a point x is equal to a. Now we say that limit of f of x as x close to a, we denote it like this, limit of the function f of x as x approaches to a will be equal to L. This is not exactly equal, it is approximately equal. Since we are not representing approximately, we use the symbol equality here, but it is not equality. It goes nearer to the value L as x approaches to a. So in general, we say as x tends to a, f of x tends to L, then L is called the limit of the function, which is symbolically written in the form of limit of a function f of x as x close to a is equal to L. Now let us discuss the limit of the function for the function f of x is equal to minus 1 if x less than 0, 1 if x is greater than 0 at x is equal to 0. Now we have to define the limit of this function at the point x is equal to 0. When I say the point x is equal to 0, so obviously it is at a origin. So for this point, I can approach the point x is equal to 0 from two directions. One is from the left hand side, another one is from the right hand side. When I say x Greater than 0, obviously the values are on the right side, and when I say less than 0, the values will be on the left side. Now when I increase the value from the right side here, as x close to 0 tends to 0 here, the value of the function is given, that is -1. When I am approaching the given point from the left side and finding the limit of the function, then that is called as the left hand limit, usually denoted by LHL. So I am finding the limit of the function f of x from left side as x close to 0 from left side. Minus indicate we are approaching the function from left side. So in that case, they have clearly given for all the values x less than 0, the function takes the value -1 here. So therefore, here the value is -1. Now let me approach the point 0 from right side. So this is right side. That means I need to decrease the value here to come closer to 0. In the definition they have given, for all x greater than 0, function takes the value 1. So since I am approaching it from the right side, it is called as right hand limit, denoted by RHL, and here we write it as limit of a function f of x as x close to 0 from right side. Plus indicates from right side. The value is equal to 1 here. So clearly the LHL is not equal to RHL, that is the left hand limit and right hand limit are not equal, they are different. So in such cases we say limit of the function does not exist or limit does not exist. So therefore, to define for a function so that limit exists, then the left hand limit as well as the right hand limit must be equal. Then only we say limit exists. And this is how we will investigate the behavior of the limit of a function. So for any point, we can approach its value from both directions. One is from the left side, which is called as left hand limit, and the other is from the right side, which is called as right hand limit. When left hand limit and right hand limit are equal, we say limit of a function exists and it has some value. If not, we say limit of a function does not exist. So now let me take one more example. F of x is equal to x square minus 4 divided by x minus 2. So let me investigate the behavior of the limit of this function at the point x is equal to 2 here. So when I say x is equal to 2, or if I apply the limit here as x tends to 2 here, f of x. So when it's close to 2, then x close to 2 means denominator becomes 0 here. So in such case, here what happens? 2 square minus 4 by 2 minus 2, which is 0 by 0. If you put x is equal to 2 here, it takes an indeterminate form. So we call it as indeterminate form or undefined form. So in such cases, limit of a function does not exist when the functions are in indeterminate form. So we cannot define the limit of a function for the form 0 by 0, 0 by infinity, infi by infinity. All these are called as indeterminate form and we cannot define the limit for such kind of function. In such cases, we can find the value which is close to 2 and hence find the limit of the given function. So now, when I am checking f of x at the point x is equal to 2, again at the point x is equal to 2, if this is x is equal to 2, we can approach 2 from right side as well as left side. So when I take the values as x close to 2 here, so if I take f of x is equal to x square minus 4 divided by x minus 2, simplify this function. Then it is x plus 2, x minus 2, here x minus 2. This can be written as a plus b, a minus b. So we will get x plus 2. So since the function is an indeterminate form, we have to simplify in such a way that denominator cannot be equal to 0 and hence I have simplified here. Now apply the limit here, limit as x close to 2, f of x. Here limit as x close to 2, x plus 2. Now let me approach it from the left hand side. So when I say left hand side, so before 2 we have 1.9, 1.8, 1.7 like that. So if you take the table, so let me take 1.9 here, then it is 3.9, 1.99, 3.99. So 1.999, very close points to 2. So 3.999. So as we go nearer to this is almost go nearer to 4. So clearly the left hand limit of this function is equal to 4. Now let me approach it from the right hand side by taking the values close to 2 from the right side. When I say close to 0, the next will be 2.01, 2.001 like that. So when I take 2.1, so 4.1, 2.01, 4.01, similarly 2.001, 4.001 like that. So here also it goes close to 0. For the points near to 2, here also the right hand limit approaches to 4 here. Now you can clearly see the left hand limit and the right hand limit of this function are equal, and hence limit exists. And what is the limit? The limit is 4. So therefore the limit of this function is 4. So we are talking about the investigation of a function with the given point as a limit. Now at x is equal to 2, as we approach x is equal to 2 nearer to a, both from left side as well as right side, the function will go close to 4 in both case, and hence we call 4 as the limit of the function f of x given. Next question is, discuss the limit of a function f of x is equal to x plus 10 at x is equal to 5. So when I say x is equal to 5 is a point, again here also I can approach it from the right side as well as the left side. So let me take a point which are very close to x is equal to 5 from left side. So that is LHL. So since f of x is equal to x plus 10 here, if I take a point 4.9, then obviously the value is 14.9. The next points like this, you can see here. For all the points which are very closer to 5, f of x is approximately equal to 15. So therefore, left hand limit of the function x plus 10 as x close to 5 is equal to 15. Similarly, if I take the points which are very close to 5 from the right side, like for example, I can take 5.1, then it is 15.1, 5.01, 15.01, 5.001, 15.001, 5.001, 15.0001. So here also the right hand limit of a function x plus 10 as x close to 5 from the right side is also equal to 15. So in both cases the function value is close to 15. So therefore here LHL is equal to RHL, and hence the limit of a function exists. So therefore limit of the function f of x as x close to 5 is equal to 15. So this is the given limit of a function. Next one, discuss the limit of f of x is equal to x cube as x is equal to 1. So when I say x is equal to 1 here, if this is x and y axis and this is a point x is equal to 1, here also I can approach it from both sides. So when I go close to 1 from left side, the functional value x cube, f of x cube is also equal to 1. So this is equal to 1. So this is our f of x. Again, when I come close to 1 from the right side also, the functional value will be 1 only. So therefore, the limit of the function from both sides, and hence f of x as x close to 1, x cube will be 1 itself. So therefore, the limit of the function exists and the limit value is 1. Next one, discuss the limit of a function where f of x is equal to 3 as a constant function as x close to 2. Now the functional value is a constant function. So here f of x is equal to 3 itself. Whatever may be the value of x you take, the value will be 3. So this is a function whose value does not change even though if you have taken a different domain. So as x close to 2, when I say this is a point x is equal to 2, I can approach from 2 direction. So therefore, the left hand limit as x approaches to left side, then the functional value of 3 will remain 3 only. And similarly, the right hand limit as x approaches to 2 from right side, the functional value of 3 for this function will be 3 only. So in both the cases, it will be 3 and it remains constant for any point in the domain because it's a constant function. So therefore, the limit of this function also exists where the constant itself is the value of the limit. Next, discuss the limit of the function f of x is equal to x minus 2, x less than 0, 0, x is equal to 0, x plus 2 for x greater than 0. Now, they have clearly given x is equal to 0 is the limit. So when x is equal to 0 is the limit, we can approach from left as well as right direction. So I am taking the left hand limit now. Limit of the function as x close to 0. So when I say x close to 0, in the left side, all the values are less than 0 and after 0, they are all greater than 0. The function is clearly defined here. Limit of the function f of x when x is close to 0 from left side. So from left side means for all the values x less than 0, function is in the form of x minus 2. So therefore, limit as x close to 0, x minus 2, if I put 0 minus 2 will be equal to minus 2. Next, I will take the RHL, that is limit of a function from the right side, close to 0 from the right side. So when I say we are approaching 0 from the right side, they are all the values which are greater than 0. And here for all the values x greater than 0, the function takes the form of x plus 2. And if I apply the limit here, it is 0 plus 2 which is equal to 2. So you can clearly see LHL is not equal to RHL. So which means the limit of the function does not exist. So if I represent through graphically here, if this is the point 1, 2, 1, 2, 1, minus 1, minus 2, minus 1, minus 2. So for all the values greater than 0, if you change the value here for all the values x greater than 0, it's a straight line x plus 2, it starts increasing from 2 from here. And here it decreases from minus 2. So therefore, they never intersect each other and the value will be increasing as well as decreasing for different values. So therefore, there is no limit for such kind of function and hence we say limit does not exist. Next one is discuss the limit of the function f of x is equal to sin x at x is equal to pi by 2. So we know the sine curve as well as the range of the sine. So sine value is always between minus 1 to plus 1. So 0 it is 0. So for pi by 2 it is 1. So again this is pi. So when I say pi by 2, it can approach from left side as well as right side. As I increase the value of x from 0 till pi by 2, you can see the curve increases and it is almost equal to 1 here. Similarly, when I take the values which are less than pi, when I take the angles which are less than pi, they also, you can clearly see, they also approaches to 1. So therefore here, so this is plus and this is minus 1. So they also approaches to 1. So as I go close to pi by 2, from the direction, in both direction, the value of x is equal to pi by 2. The functional value will be equal to 1. So that is the limit of the function as x close to pi by 2. Sin x is equal to sin pi by 2, whose value is equal to 1. So therefore, the limit of this function exists. So always remember that the limit cannot be defined only when the left hand limit as well as right hand limit are not equal. If both are equal, we say that limit of the function exists. So in this session, we have learned the definition of the limit and we have discussed the behavior of certain functions with the limits. And we have discussed the behavior of some function under the given limit conditions. We cannot define the limits if it is in the indeterminate form. Only when the functions are in the determinate form, we can apply the limit. One more thing is, we can find the limit of the value if it exists, and L will be taken as the limit of the function. So, limit of a function can be 0, but it cannot be infinity. So, I'll meet you in the next session with a new concept. Until then, keep watching, keep learning, and keep exploring. Thank you.